Again, welcome to Java Programming Language, CS 102. In this lectures, we're going to learn how to write classes. That's writing classes. That's a user-defined classes. In our previous lectures, we learned how to use the predefined classes that comes with the Java application program interface. Example will be the string class and also the math class. So for example, if I want to find the square root of a value, I don't have to, again, write a function because it's already included in the math class, the square root method in the math class. These are, again, predefined classes. So again, these lectures, we're going to learn, these lectures cover chapter 4 of our course textbook. We are going to learn how to define a class, or class definitions, what is an instant data, and also encapsulation, which is very important with object-oriented programming. As we said in our previous lectures, object-oriented programming focus on three main things. One of them is encapsulation. We also have the inheritance, which is very, very important also. So here also we're going to learn how to declare a method or method declaration and parameter passing. And most important, what is a constructor? A constructor is a very special method that always, anytime we want to create an object from a class, that method is called to create the object, to initialize the object. So our main objective, again, anatomy of a class. In this lecture, we're going to cover everything about classes. So here we say programs. The programs that we have written in the previous example use a class defined in the Java API. These are predefined classes that is given to us by Java program. Now we are going to learn how to design our own programs, and these programs will be relying on classes. So we're going to learn again how to write, define classes, and also how to use classes. So classes that contain the main method is just the starting point of a program, and that's the main class. True object-oriented programming is based on defining classes that represent the object with well-defined characteristics and functionality. So for example, we may have a class named student. The attribute of a student can be, attribute is the same as the characteristics, which can be name, address, major, and GPA, or grade point average. Now operations is we can set address, set major, and also compute the grade point average. So from this example, we can see that always a class consists of two things: the attributes of the class and also the operations of the class. The operations of the class becomes the methods of the class. Then the attribute of a class becomes the data or the instant variables, the data members. Another example we have here is rectangle. The characteristics of a rectangle can be it has a length, it has a width, and also it can have a color. What operations we can perform on rectangles? We can set the length, we can set the width, we can also set the color, or we can even find the area, compute the area of the rectangle. Next example is aquarium. Aquarium is a class, and the characteristics of aquarium will be the materials, the length, the width, and the height. The operations we can perform on aquarium can be, we can set the material, and also we can set the length, the width, the height, and also we can compute the volume of the aquarium, or compute the field weight of the aquarium. Another example is a flight, a class named flight. The attribute can be the airline, the flight number, the origin, city, destination city, and current status. Operation is that we can set the airline, set the flight number. Also, we can determine the status of the flight. Another example is employee class. The attribute of employee can be the name, the department is working at, the title, the salary. Then the operations we can perform is we can change the department of the employee. So set department, we can set his title, set salary, we can compute the wages, compute bonus, and compute taxes. So what is a classes and objects? Now, if we can recall from overview of objects, which we cover in chapter 1, we discuss about a class, and we also discuss about object, and we say object always have a state and behavior. The state later can be the characteristics or the attributes. Behavior will be the methods. So example given here is we should consider 6-sided die, the singular of dice. Its state can be defined as which face is showing, and the possible faces can be 1 to 6. Now, its primary behavior is that it can be roll. So we can roll a dice, and then we may have 1 or 2 as the face showing. Now, in this case, we can represent the die by designing a class named die that models the state and behavior. So the class serves as the blueprint for a die object. So after we create the class die, now we can use the class to create the real object of the die. So now, in this case, we can then instantiate as many die objects as we need for any particular program. So I create one class named die. Now I can create as many dice I want object from the class. It's like building a house. The architect may have one blueprint design of the house, but he can build as many houses he wants using the same design. So here we say a class can contain the data declaration and the method declaration. So the data declaration will be the characteristics or the attributes, and then the method declaration will be the behavior. So example here, we have a class. The data declaration are the size, weight, and category. Then we can have a method declaration. Now, the values of the data define the state of an object created from the class. That's why when we're creating the object, we are going to initialize the constructor. If we have a specific height, we have to specify the height in the constructor, because that's what, again, we are going to create the state. So we say the values of the data define the state of an object created from the class. Also, the functionality of the methods define the behaviors of the object. Now, for our die class, we might declare an integer called face value. So the face value can be any value between 1 to 6 that represent the current value showing on the face. One of the methods will to roll the die by setting the face value to a random number between 1 and 6. Now we will want to design the die class so that it is versatile and reusable resource. Any given program will probably not use all operations of a given class. So let's see this example. So here we have a rolling dice.java, we have die.java. Die.java file will be the class of die. Then the method, the testing program will be rolling dice.java. So here we have the rolling dice.java. So our main class name is rolling dice, since that's the name of the file. Then here we have a main method. Now you can see here we are creating 2 die objects, die 1, die 2. Then we have a variable sum. And this variable will be the sum of the die result will be stored. So here we create our first die, name die 1 and die 2 using the new. Again, new is a very dynamically allocated memory space. The new keyword is used dynamically to allocate memory space. So here we are allocating memory space for object die 1. Now we can write this in one line. We can start with the name of the class die. Then we say die 1 equal to new die. Then die 2 equal to new die. But here we already declared the die 1, die 2 as die. Now we have the object. What we want to do, we want to roll both die. So die 1.row, die 2.row. So this means in our class name die, we should have a method name row. So system.out here we say die 1 plus die 2. So we have the results. So here we say die 1 result which we roll, and then die 2 result that we roll. The plus sign here, as we said earlier beginning, we can use it to concate two strings or one string and one value. So we wrote die1 again. Then we set die2 face value to 4. Then we print them. Now we sum die1 and die2 results. So die1 dot get face value, die2 dot get face value. So this method also will be in a die class. So we'll see it in a few seconds. Then we print the sum. Then we sum die1. We wrote die1 and die2. We sum the result and we print it again. So most important thing is, let's go straight to the die.java. So this is our class name die. It has a mass as a constant variable 6. That's the maximum face value. Then we have a special variable, private int, face value. Private means only this method in this class named die can directly access the values of these two variables because they are private. So other classes outside this class cannot directly access them. So first we have our constructor. We set our constructor to the face value to be 1, which means anytime we create a die object, the face value is always 1. Then as we said, we have the row method, which is going to randomly give us a value between 1 to 6. Remember the mass is 6. So here we say math.random times 6 plus 1. Then next we set the face value. So we assign the value to face value. Then we get the face value, we return the face value result. And we always get the face value when we call the row method. Then we have our special toString method that will represent an object data in string. So here we say the die class contains two data values as we saw in the constant mass value, which is 1, to represent the maximum value, face value. Then an integer face value that represents the current face value. We also have the row method as we saw it, which uses the random method to give us value between 1 to 6. There are also methods to explicitly set and also retrieve the current face value at any time. Now we also have the toString method. Now it's a very good practice to define a toString method for a class. So toString method again is a special method that always returns a character string that represents the object in some way. And this toString method is automatically called when we create an object. And an object is concatenated to a string or when it's passed to the println method. Also, it's very convenient for debugging problems. We also saw a constructor. As we said earlier, a constructor is a special method that is used to initialize an object when it's created or set up an object when it is initialized. Also, the constructor has the same name as the class name. So if my class name is die, as we saw it earlier, we can see that our constructor also is a die. So the class name is die, the constructor is die. No returning type and also no argument, which is default. So as we said, as mentioned previously, a constructor is used to set up an object when it is initially created. Also, a constructor has the same name as the class, and also the die constructor, as we saw it, is used to set up the initial face value of each new die object to 1. Because in the die constructor, we saw that the face value is set to 1. Now we examine the constructors in more detail later in this chapter. So what is a data scope? Now, a scope of a data is the area in a program in which that data can be referenced or used. So data declared at a class level can be referenced by all methods in that class. But also data declared within a method can be used only in that method, not in the class. So data declared within a method is called a local data. And in the die class, the variable result is declared inside the toString method. So it's a lookup so that the method cannot be referenced anywhere else. We also have instant data. An instant data here, we say when a variable declared at a class level, such as face value, is called instance data. So instance data is when a variable is declared at the class level, not the method level. So each instance or object has its own instant variable. And also a class declares the type of data, but it's not reserved memory space for it. Now, each time a die object is created, a new face value variable is created as well. And also the object of a class share the method definition, but each object has its own data space. That's the only way two objects can have different states. So this is an example of instant data. We can show that the two die objects from the rolling dice programs are followed. So die 1, we have 5, die 2, we have 2. Now each object maintains its own face value variable, and that has its own state. Now the UML stands for Unified Modeling Language. This is a very special modeling language that can be used to design classes. So we have the class diagram. The UML comes with around 14 different diagrams, from activity diagram, sequence diagram, use case diagram, class diagram. But again, we can use the class diagram to design our class. So here we say UML class diagram consists of one or more classes, each with sections for the class name, the attributes, and operations or the method. So that's an example of a class diagram. We have a rolling dice, the main method, returning void. Now we have a die. This is the class die. So the instant variable is only one, that's the face value, and it should be int, a value between 1 to 6. Now we have a lot of method here. We can roll a die. We can also set the face value to any value we want. We can also get the face value. And we can also use the toString method. So we have a quick check here. What is the relationship between a class and an object? Here we say a class is the definition, the pattern, blueprint of an object. It defines the data that will be managed by an object, but doesn't reserve memory space for it. So again, multiple objects can be created from a class, and each object has its own copy of the instance data. Now, where is the instant data declared? Always the instant data is declared at the class level. So when we, again, create a class consists of data members and method. Those data members in the class is called the instant data. Now, what is the scope of instant data? This can only be referenced by any method of that very class, especially if it's private. Now, what is a local data? Here we say local data is declared within a method, and it's only accessible in that method. Again, we're going to discuss more details in our next program on user-defined classes. Again, this lecture is covered chapter 4 of our course textbook. Thank you.